Welcome to the NetRise breakout session at ESCAR EU 2023. In this relatively short session, we are going to cover at a high level how automotive companies are leveraging the NetRise platform to address some of the more pertinent challenges and risks that exist in the automotive security space. So we'll start with just a couple slides, kind of set the table. Not going to spend too much time on that. And then we'll jump into a bit of a platform demo again to really show how our customers are leveraging our platform to address some of these challenges. So to jump right in here, we have about 25-30 minutes or so. You know, everybody that is attending this conference very likely is pretty well in tune with the threat landscape that exists in the automotive space. It's a pretty complex threat landscape, right? New vehicles that are coming out on the market have as many as 30,000 or more components. Part of this being due to the fact that there is a very complex supply chain. You have your tier ones, your tier twos, multiple tiers of suppliers that are supplying components for these vehicles. It's obviously a fairly well or heavily regulated industry as well. Something that we're seeing in other industries as well, but certainly in the automotive space, there's regulation that's driving supply chain risk management and software bill of materials, which is going to be a focus for what we talk about in this breakout session. But I think a lot of this drive towards just SBOM, is maybe not shining as much of a light on some of the other risks that exist outside of one JSON document or one SBOM for a particular vehicle or a set of components within a vehicle. So there's a lot more to the story that we're going to cover in this breakout session today as well. So to kind of continue on talking about that complexity of the of the threat landscape. This is a multi-headed issue for automotive device manufacturers, right? So you have the challenge of securing the automotive components themselves, but then also this being a heavily manufacturer-focused industry, you have challenges around securing the manufacturing floor as well, right? So there's certainly a lot of research that's been done as of late regarding attacks that have occurred on vehicles themselves, but there is also an uptick really across all industries on attacks such as ransomware attacks, targeting the manufacturers themselves and therefore the manufacturing floor. Again, from the latest research that has come out, there doesn't seem to necessarily be a specific focus or target that can be drawn in the automotive industry. Attacks are more opportunistic. However, somewhat unique to the automotive space, attacks that are successful, such as, again, a ransomware attack, can have a huge impact on the industry as a whole due to the complex supply chain that exists, where these supply chains are very largely intertwined, right? So you have one supplier that may be a tier one supplier for multiple additional vendors that if they get hit, manufacturing stops, it can have a very large impact in the downstream supply chain. So some of the problems, which we've touched on a little bit up to this point, but to go into a little bit more detail, some of the challenges and problems that are faced is, again, SBOM is a huge focus. There's a lot of regulation driving this. People or organizations are trying to decide what is the best way to generate an SBOM. Again, with these complex supply chains, there are challenges with, for example, using something like a software composition analysis tool that relies on having access to source code when you very well may not control all of the source code. I think would be extremely rare, but in many cases, it may be more than 50% of the source code is not controlled. But you're still liable, and you still have to generate SBOMs for these components that are in use. in tune with SBOM generation, I think one thing to mention is SBOM management and operationalization as well. I think a lot of organizations are starting to get to the point where they're generating some SBOMs. It's probably not perfect, but then you're left with the question of how do I operationalize them? How do I manage them? How do I share them with customers? Which really is a whole other challenge that exists in the space. Going along with that, vulnerability management really goes hand in hand. One of the primary use cases of an SBOM is to identify known vulnerabilities that exist in the software components that exist within a top-level component, and prioritizing and managing those vulnerabilities can be a big challenge, right? You end up with an SBOM that may have thousands of vulnerabilities in many cases, where it's really important to prioritize those and determine what are the vulnerabilities that are actually posing the most risk, what mitigations are available that can be put in place, are there patches available, and most importantly, where am I affected by those vulnerabilities, right? If you identify a vulnerability for one component or one device, the ability to very quickly identify what other components or devices have that vulnerability is very important, and something that we'll talk about how we're addressing that problem when we get into the platform. Remediation workflows, again, really hand in hand with vulnerability management, is what can I do about these vulnerabilities, and really fostering a relationship between security and engineering to say, security being the kind of the gate of prioritization, and then a clear way to communicate to engineering why these things need to be fixed and how they need to be fixed. Compliance adherence is certainly big in this space, as we've already talked about. Many compliance frameworks that exist, and specifically regulations that are pushing SBOM. Risk identification, this is what we talked about on one of the earlier slides, is SBOM is not the end of the story. Even when it comes to specifically supply chain risk management. But when you look at the components and devices that we're dealing with, there is so much else that exists outside of just software composition analysis, component identification, and vulnerability identification that introduces risk that is not necessarily tied to a CVE, right? So things like default credentials or misconfigurations, or issues with public keys, private keys, certificates, all of these other additional items that you don't see in software bill of materials, very often can pose significant risk that, again, need to be prioritized. And in order to be prioritized, they need to first be identified. So last few here, CI/CD integrations. This is something that really is ubiquitous across all industries. Is the ability to take tools and integrate them with your processes that currently exist, which is something that we heavily focus on here at NetRise. Everything that we do is API driven. We can very easily integrate with CI/CD pipelines as far as data coming in, right? Uploading firmware, binaries, other inputs into the platform. As well as data coming out, right? So again, prioritizing data within the platform, and then creating tickets and integrating with a SIM or some sort of ticketing system to get the data to the folks that need it. Incident response, again, this is really relevant across all industries, but something that I talked about before when we were talking about vulnerability management is the ability to have this level of visibility into everything, right? Every component, every device that exists, and having that in one place where it's very scalable, and the ability to correlate data across all of your components and devices and artifacts to instantly be able to answer the question, where am I affected, right? When the next log4j, log4shell type of incident pops up, and there's a new vulnerability in a pretty ubiquitous software component, the ability to come into one place, run a query, and get a result back that tells you here are the 5 places that are affected, the components, the devices that are affected, is an unbelievably massive time savings compared to very manual processes that many folks are kind of stuck with today. Tool consolidation, again, kind of going hand in hand with some of the other things that we've talked about, but having the ability to manage your SBOMs and generate your SBOMs and identify all this other risk all in one place, all in one platform, can really help with consolidating security tools as well as streamlining security processes as a whole. And again, we're going to spend the second half or so of this breakout session walking through the platform and talking about as much as that, or as much of that as we can within a 25 to 30 minute time frame here. So just a very quick introduction into the NetRise platform and what our solution does, and then we'll jump into a bit of a working session. So the platform as a whole it's a cloud-based platform. It's a cloud-based SaaS platform. The input into the platform is typically a binary artifact, so something like a piece of firmware or a software package, or we also have the capability to analyze things like cloud containers, virtual machines, Docker images, etc. The point is that the NetRise platform does not require access to source code, right? So it gives you the ability to generate software bill of materials and identify all of these other risks that we talked about without relying on the fact that you have access or you have control over the source code or the input. So the input is a binary. The platform takes that binary, rips it apart, it extracts it, identifies software components, generates that software bill of materials, correlates and prioritizes vulnerabilities, and identifies all of those other risks, again, that exist outside of SBOM and vulnerabilities, puts it into a very digestible report. Again, prioritization being a big focus of that. And then through our APIs, again, we can integrate with CI/CD pipelines, CI/CD tools, ticketing systems, SIMs, etc. So with that, we'll spend the rest of the 15 minutes or so jumping into a bit of a demo and walkthrough of the platform. So something that we talked about at the beginning was this is a complex kind of multi-headed issue, right? So you have the challenge of securing the the components and the devices that are shipping and going onto the vehicle. So the more product security focused use case, and then you also have the use case of securing the manufacturing floor, right? Interestingly, in the automotive space as well as a handful of other industries, the challenges that you face in securing those environments are fairly similar. And the reason they're similar is because there is so much firmware and embedded devices that exist in those environments. And there is significant underlying risk that exists that you're essentially blind to if you're not able to go this deep and do this level of analysis on those types of devices. So one thing that I want to highlight first is there is multi-tenancy in our platform. Now you can leverage this multi-tenancy for a variety of use cases, but the one I'll talk about here is for this demo we have two different environments, right? So we have our product security environment where we have two different firmware images loaded up, one from an ECU, one from I believe a entertainment system or head unit, and then we also have a totally separate environment for the enterprise, right? What we call the enterprise, which that would be the manufacturing floor in this case, right? Where you have all sorts of manufacturing devices, PLCs, networking equipment, again, all of these devices that are similar to the things you find in vehicles, embedded systems, where the lack of visibility can be a very significant risk. So for the enterprise environment, we just threw a couple sample devices and firmware images in here, so things like security cameras and networking devices and PLCs, etc. And then if we jump into the product security instance to go back to this, again we have, if I refresh, we have two different devices in here, and we have an ECU firmware and a head unit firmware. So we'll jump into a report here. because we don't have a ton of time, I won't spend too much time talking about the dashboard. But if anybody is interested, of course, which I'll mention at the end as well, please reach out to us, and we're more than happy to do a full demo of the platform where we can really showcase the full capabilities. So if we jump into a report here, we can come in and look at the results, and again, you see a summary page that has high-level results from basically each of the areas of analysis that we have. And one thing that I want to call out is everything that you see in the platform is click-through, it's drivable. So for example, if I wanted to say for this particular ECU firmware, I want to see all of my critical vulnerabilities. Okay, great, I can click here very easily, get pulled into the vulnerabilities tab, and have that displayed in real time to me, right? That same thing is true for everything else that you see in the platform. We could click on anything in here and be taken to see exactly what we're looking for. Now, something that we talk about all of our customers with is, you take a look at this particular device, prioritizing through, let's say, CVSS critical and high is probably, in all honesty, not feasible, and really just not the best strategy, right, to prioritizing vulnerabilities. I mean, if you just do some quick math, we're looking at over 1,500 vulnerabilities that exist just in this one device. If we were to prioritize based on CVSS critical and high, which is really what many organizations and vulnerability management programs suggest. So again, as I mentioned during the slides, one of the things that we heavily focus on is prioritization of not only vulnerabilities, but really all of the data that we're pulling into these reports. But for this, the purpose of this demo, we'll focus on vulnerability data. So for every CVE that we identify, we pull in hundreds of sources of threat intelligence to say, okay, at the top level, we have 3,400 or more vulnerabilities, but how many of those actually have known exploits that exist, right? And going a level deeper than that, do the exploits exist on something like the CISA known exploited vulnerabilities list? Are they associated with known threat actors or APT groups? Are they associated with known named attacks like Ripple 20, for example, or going way back, Heartbleed, Shellshock, things like that? Are they being used in botnets? Or are they actively being used to drop ransomware payloads? So this level of prioritization can take you from, as a first step, take you from a pretty insurmountable number of vulnerabilities to just focusing on the vulnerabilities that fall under these categories, which bubble up to this category that we call weaponized, right? Meaning the vulnerability exists, and again, it falls under one of these categories that you see here. So just like we saw before, I can click here very easily and now be taken to a subset of the vulnerabilities that, again, not only do they exist, but they also have weaponized exploits. So now we're looking at 43 vulnerabilities. Now, another thing that we can do to prioritize that I do typically suggest, certainly at a first pass when you're looking at these things, is let's also prioritize by vulnerabilities that have the attack vector being over the network, right, or external. Certainly not saying that local access vulnerabilities don't matter, nor are we saying that vulnerabilities that don't fall under this weaponized category matter. But if we are going to look at the things that we need to remediate first, right, that are posing the most risk to the device, certainly you could say it's an opinion, but I think it's probably a pretty agreeable opinion that the vulnerabilities with weaponized exploits that are attackable over the network without requiring local access is probably the one of the best places to start. So now here we have a list of 14 vulnerabilities that exist, which is much, much more manageable, right, than a list of 3,000 or a list of even 43, or if we looked at the critical and high example, a list of 1,500 or whatever it was. And another thing that I really like to call out here when we show this is, if you look at the CVSS severity of these vulnerabilities, many of these vulnerabilities, in this case it's about 3, but so often we see vulnerabilities that are medium or even low severity. So A more traditional prioritization strategy that says criticals and highs is not only are you, kind of burning time chasing down vulnerabilities that have never been exploited in the wild, but you're also missing vulnerabilities that have a lower CVSS severity that do have known exploits that have been exploited by threat actors. So, for example, if we just take a look at this medium vulnerability in OpenSSL, anytime you see a vulnerability that exists, you can always expand it. And this is where we're aggregating all of the additional threat intelligence and references and research and security advisories, again, from more than 100 sources that we're aggregating to give you as much information as possible so that you can make informed decisions about the level of risk that this vulnerability is posing to your environment, mitigations that can be put in place, patches that may be available, etc. Another thing that we talked about was the existence of a weaponized exploit. For any instances where we do find exploit code that exists, we will point you directly at that exploit code, right? So here we can see, we can very easily click on weaponized exploits. I can expand this out, and here we have, a live link to an exploit that exists for this particular vulnerability that, again, in this case was a CVSS medium, right? One other example that I'll show here is we'll show one that exists on the CISA known exploited vulnerabilities list. This one happens to have 44 known exploits. Again, we're providing you all of this additional threat intelligence and references and information, in this case related to the CISA KEV list, when it was added, when the due date was or is for getting patched, which is typically 2 weeks after that vulnerability gets added to the CISA KEV. And again, this one we see falls under a number of categories, right? So it's on the CISA KEV, so we have that information. It's associated with a known group or known threat actor group, in this case Raspite. So we have live links there. And again, this one has 43 individual exploits, all of which we provide references and links to. So, again, that just highlights at a pretty high level some of the vulnerability prioritization data that we pull in to help you get to a much more focused list of vulnerabilities to take a first pass at and prioritize. A couple other things that I want to show here that we talked about on the slide. So, from an incident response standpoint, let's say that we identified this CVE, and this is the next log4j, this is the big ticket item that we need to know everywhere that this thing exists in our environment. Well, something that we do with every data point that we have, whether it's a component in the SBOM or a misconfiguration or a set of credentials or anything else that you see here, is we in real time correlate all that data across all of the devices or assets that you've uploaded into the environment. So for example, this particular CVE is found, as we see here, in one other asset, and I can very easily click here and it's going to show me hey, not only is that CVE in this ECU firmware that we're looking at, but it's also in that head unit firmware, right? And imagine a scenario where you have hundreds of devices and hundreds of components and being able to do that correlation in real time. So, we're running up on about 5 minutes or so left. So I do just want to make sure I get through the rest of this report very quickly to just kind of show some of the other things that we're doing. So for example, if we come into the SBOM, which again is really a big focus for people now, one thing to mention is not only do we generate SBOMs in this platform, but we also manage and operationalize them if, let's say, you have other tools where you're generating SBOMs, and again, you want to have them all in one place where you can search, sort, filter, query, export, do whatever you want with them. The NetRise platform can be that solution, right? Not only can we generate the SBOMs from compiled images, but we can also ingest SBOMs, do all of that vulnerability correlation and vulnerability prioritization that we just talked about. We support both industry standard formats, CycloneDX and SPDX. We also include known unknowns in the SBOMs that we generate. SBOMs are not just there to identify known third-party components, right? SBOMs are also there. Really, the use case for an SBOM is to identify all components that exist in an image or in a device or in a given piece of software. So according to the NTIA, which only makes sense, if you're not including known unknowns or components that are not associated with known third-party components in your SBOMs, you are not meeting the minimum standard that the NTIA defines for SBOMs. So we allow you to configure your SBOMs when you export them from the NetRise platform. Do you want to include vulnerabilities or known unknowns, for example? And again, we support all of the industry standard formats that you would expect. There are many ways to group, organize, and filter and search through these that we won't have time to go over in this short session, but as a quick example, if I wanted to say, hey, group by license type, right? I could very easily group my SBOM by license and see all of the licenses that are in use, get a very easy to digest report. And, for example, if, let's say, oh, we're not supposed to be using this BSD2 clause license, I could just drop this down and see all of the different components that are using that license that, again, for some reason we're not supposed to be using. So tons of different ways to group, again, sort, search, filter, and operationalize these SBOMs that we're more than happy to go through if you stop by our booth. We can talk about SBOM, we can talk about any of the other vulnerability data and risk identification that we can do, and certainly happy to set up further demos as well. Just to touch on a couple of the last pieces here, we do identify device misconfigurations that exist, looking for things like insecure coding practices or, very simple Linux hardening items, right? If you're looking at an embedded Linux image, so for example, your sudoers file is missing, or you're using weak hashing algorithms. These are all, in many cases, low-hanging fruit things that we can identify that can very easily be addressed to build more secure products. We identify all of the binaries on the system, looking for weak binaries, binary protection mechanisms, cryptography. We identify certificates, public keys, private keys, and we will tell you if there are issues that exist within those keys, right? So if certificates are expired or maybe self-signed by an untrusted authority or something else, or in the case of public keys and private keys, we tell you, did we identify the key pair, right? If we find a private key, we say, hey, did we also find the public key, or vice versa, which is something that we see very often in firmware that, again, is not related to SBOM or vulnerabilities, but can pose very significant risk to the device. Credentials, if applicable, we will show you any credentials identified both in Linux authentication locations, so things like etc password, etc shadow, but in the case of even Linux images or non-Linux images, any hashes that we identify anywhere on the system, right? So this could be embedded in a shell script or a config file or a binary or wherever it may be. We'll identify those password hashes, and we will also crack those passwords. We run all password hashes through a password cracking rig, and we have a very high success rate at cracking passwords that we identify. So again, another item that is not tied to a CVE, but that very often poses significant risk to the device. We have a file system tab where you can come in, explore the file system that we extract from the asset that was uploaded. You can download individual files. You can always download the original asset or the extracted asset. And then the last thing that I'll mention as well that we have is a search capability to either search through all of our raw parser data if you wanted to search for log4j or a vulnerability or a specific credential or a private key. You could very easily come into our search and do that. And then the latest feature that we've released is what we're calling our trace AI search, which allows you to search for search semantically using natural language for anything that may exist in interpreted languages, right? So things like Python or shell scripts or Lua scripts or JavaScript or configuration files, anything that is plain text-based. We have the capability to search for anything that you're looking for semantically rather than a keyword search, right? We do have the capability to do a keyword search, but for example, we probably won't even be able to show the results here before 30 minutes comes up, but if I wanted to search for a Python network socket is created and connects to a system which can then send data to bin bash, right? So searching for intent and functionality rather than searching for a specific set of strings or characters, I can do that, right? You can run a search, it will return you results, and then you can go and remediate those issues or remove whatever that vulnerability may be. We also have a preset list of over 2,000 rules and queries that we've tied to things like the OWASP top 10, to CWEs, etc., that you can set up as pre-canned searches to say, hey, every time I run an image through this platform, I want to run these 10 searches and get a report back specifically on the results that come back there. So we're pretty much up on time here. As mentioned before, this is a super high-level overview of the platform. Please stop by our booth this week at the conference, or reach out to us. Go to our website. Again, stop by the booth, get our information, send us an email, and we're more than happy to do some more in-depth demos, walkthroughs of the platform, and talk about use cases and answer any questions that you might have. So appreciate the time in this quick little breakout session, and we'll talk to all of you soon. Thanks.